So please make it live.
Participants are there.
Already we received around 5,000 people are there. They are logged in.
Okay. So, shall we start?
Yes,
Live now?
please. Yes.
Okay. Good afternoon, all. Welcome in today's afternoon session. Today, to make us aware of the planetary geology, we have among us Director, Indian Institute of Remote Sensing, Dr. Prakash Chauhan. I'll take the privilege to introduce him to all of you. And Dr. Prakash Chauhan obtained his master's degree in applied geophysics from Indian Institute of Technology, Roorkee, and PhD in physics from Gujarat University, Ahmedabad. Dr. Chauhan joined Indian Space Research Organization in year 1991 as a scientist, and since then he has been working for the applications of remote sensing technology for natural resource management for ocean and land cover resources. He has done leading work in using hyperspectral data for lunar surface composition mapping using HIC and moon mineralogical mapper instruments of Chandrayaan-1. He has been principal investigator for the infrared imaging spectrometer IIRS instrument based on Chandrayaan-2 mission. He has published more than 100 research papers in both national and international journals. Dr. Chauhan is the member of ISRO NASA Planetary Science Working Group and fellow of National Academy of Sciences, Allahabad. He has been awarded prestigious Professor P.R. Pisharuti Memorial Award for 2004, Hariom Ashram Prerit Dr. Vikram Sarabhai Research Award for 2009, ISRO Merit Award 2010, Satish Dhawan Award 2016, to name a few. Now, on behalf of everyone, I welcome Director IRS, Dr. Prakash Chauhan, to share his thought. Welcome, sir. Please.
Thank you, Richa, for this introduction, and thank you to Harish and all my colleagues from Indian Institute of Remote Sensing. And I welcome once again to all the participants of this program, which we are organizing mainly for our school teachers, with an idea that we would like to give you an overview that how the space technology is being used for the benefit of common man, as well as what are the recent advances which in my view, you must be aware so that you can also, kindle the excitement and curiosity of the young students in your schools whenever you are teaching them. So in continuation of this series, today I'm going to talk, something about the geological, or you can say the landforms of different planetary bodies. Mainly, I will be focusing on our satellite moon and our nearest neighbor in terms of solar system, which is Mars. As basics of solar system and our planetary system was covered yesterday by Dr. Anil Bharadwaj, I will not go into details of that. I will quickly take you to some of these beautiful worlds, and when you go close to them, especially with the help of our satellite-based observation capabilities, how does this world look like, how different they are with respect to our own planet, and how similar they are with respect to our planet. You will be getting an overview of, especially for our moon as well as for the Martian surface, which has been most of the examples which I will be showing in this talk are mainly from our Indian exploration missions, namely Chandrayaan-1, Chandrayaan-2, and Mars Orbiter mission. So with these words and the background, let me go to the next slide. As you have been listening since last 2 days about the Indian space program and its vision, in the first talk, Director VSSC has given you a comprehensive idea about the various facets of Indian space program. I would only like to, just remind you that the Indian space program was started with the visionary efforts of Dr. Vikram Sarabhai, whose birth centenary we celebrated last year. And his vision was that a country like India, especially in those days, in late 60s and early 70s, we are still a developing country, but our economic situation was much, much weaker. At that juncture, he had the courage to tell to the countrymen and to the top management of the country, especially the government, that yes, the space technology can be of use, for the development and for the betterment and upliftment of lives of millions of Indians. And he started the Indian space program with a vision that we should be second to none in the applications of advanced technologies to the real problems of man and society. So today, with the help of state-of-art technology, with the help of industry, which was talked about, the role of industry was talked about with Dr. Somnath, with the help of academic institutions, in last more than 5 decades, Indian Space Research Organization has conceived a totally indigenous, what we call today as Atmanirbhar, Indian space program, which has different facets, which you learned about the space transportation, space infrastructure, space science program, and the applications of Earth observation and other communication and navigation satellite data for solving the problems of each one of us, and also making our life much more comfortable. Today, when you draw money from your ATM account, you may not realize that there is a reset sitting at the top of these ATMs, which is connected through satellite-based communication system. So this is how the seamless, use of space technology today. When you drive your car and when you navigate from your home to your office or to some other shops or to some complex or shopping mall, you use, the navigation technology, which takes you through a map, and you don't realize that all this information is basically having a connectivity with satellites which are orbiting, around the Earth and providing you the location-based services. So, with these ideas which were conceptualized almost 4 or 5 decades back, today we are seeing the fruits of this Indian space program in terms of complete Atmanirbhar or indigenous efforts. Now, if we talk of our reach into the solar system, you must have heard that we have launched large number of space assets and satellites into what we call as the low Earth orbit, which is basically from 500 kilometer to 900 kilometer from the surface of Earth. We have also put large amount of satellite systems in what we call as the geostationary orbit, mainly to provide communication as well as meteorological services. We have also traveled a far-off distance of around 385,000 kilometers from the surface of Earth, not only once but twice, in the form of putting 2 satellites, one, the Chandrayaan-1 in 2008 around the surface of Moon, and in 2019, when we returned to Moon with our next mission called Chandrayaan-2, we not only successfully put an orbiter around the Moon again, but we were also attempting to land onto the southern pole of the Moon, and we almost made it till our lander, which has reached as close as 200 meters to the Moon surface, finally did not soft landed at the Moon surface, and it basically toppled. So that has also given us a big amount of lessons. And then you also heard yesterday about the journey towards the Mars, which is around 200 to 225 million kilometers from the surface of Earth. And India became the first country in 2014 to successfully insert an object, man-made object, and which was known as MOM or Mars Orbiter Mission, around the surface of Mars in the first attempt itself. So, as you can see, our presence, the presence of Indian-made objects is there, from almost, you can say, from 500 kilometers to all the way up to 225 million kilometers as we talk about the Indian space program. So this is basically, in one slide, I about the 50 years of journey of Indian space activity and the kind of space assets which we have created for various aspects in terms of using the space for applications for deriving knowledge about planetary bodies to provide communication services or to provide the navigation services of this country. Now, that was something about the space segment, which we call it the upward, linkages. Now, when you put a satellite into space, the satellite does certain functioning. If it is a communication satellite, it will have a transponder. If it is a remote sensing satellite, it will have camera systems. If it is a navigation satellite, there is an atomic clock, which keeps track of the ranging and the time of receiving and transmitting the signals from which you can accurately reconstruct your positions, or the exploration satellites, which have different type of sensors, can capture various amount of different type of data sets about those planetary objects. Now, all this data, which is captured by the satellite systems, has to be transmitted back to Earth, because we are the users. The humans are the users of this data. And today, in our solar system, we are still searching for life in other planets or in other moons of different planets. And the big question is that, are we alone in the solar system or even in the universe? Because we have not come across, even though our civilization is one of the most intelligent civilization, what you can call. And today I can tell you that I have no hesitation in saying that we are living probably in the golden or platinum era of human civilization, where we have all kind of technology in our hand to solve various problems of humankind. But in spite of all this progress, we have not come across any other form of life other than planet Earth. That's why on this planet, which is our home planet and which is also there in the solar system, we also put what we call as the ground segments, or antenna systems or communication systems, which communicate with these satellites to receive these satellite data sets. And this is one example, especially in the context of planetary exploration, because we are sending satellites to far off places like Mars, moon of Earth. Then you also heard that we have a program, program is being planned to go to Venus. And then there is also a mission which is being planned in Lagrangian positions for studying the sun. So these far off objects, when they send the data, the distance is very large. You have to build large aperture antenna systems. So this is one of the such large aperture antenna system, which is part of what we call as the Indian Deep Space Network, IDSN. And all the data sets from which is acquired by the satellites over different planetary surfaces is transmitted back to such type of deep space network, which are located across the globe. So India also collaborates with NASA and with other space agencies, to acquire this data at their locations, and then later on this data is transmitted with the help of terrestrial communication network. So we have a beautiful Indian Deep Space Network, which is here in Bailalu, in Bangalore. It is having a 32-kilometer antenna to receive signals from as far as places as like Mars, which is around 225 million kilometers away. And this is the control room, and there is a good amount of publications, and there's a book also on the story of Indian space deep space network, how it has been conceived, conceptualized, and how such kind of mega infrastructure has been developed in this country to communicate from far off objects. Now, I'll come quickly to the topic of today's concern to each one of us. We will be initially talking about our own satellite, which is Moon. And this is a beautiful picture of Earth and Moon system. Moon is a part of the Earth system itself. It's not separate. And it is basically, what we can say is a kind of object which is umbilically tied to the Earth, and it goes around the Earth due to the gravitational influence both of Moon and Earth. Now, this picture tells you something very drastic. First of all, how the Moon goes around the Earth. Then it also shows you the backside of the Moon, because this photograph had been taken from a satellite which is, operating from a distance which is basically more than the distance of Earth and Moon. So from that configuration, this image has been captured. And this image basically tells you two things. if you want to compare both Earth and its own natural satellite Moon, the diameter is almost roughly one-third. Moon is almost one-third of Earth's diameter. Earth is having a tilt of around 23 degrees on its axis, but Moon does not have that much tilt. It is only tilted around 7 degrees. So there is no seasons. Seasonality is not there on the Moon. Earth has very comfortable temperature so that we all can live here comfortably. And as and when the temperature fluctuates to extremes, we also have developed now different mechanisms like heating and cooling mechanisms too, so that we can remain comfortable. But that comfort, if you are landing on the surface of Moon, you will not experience that, because during the daytime, the lunar day itself at a given location is equal to 15 Earth days. So if you are at a location on Moon, you will be receiving continuously for 15 Earth days the sunlight, and the temperature can go as high as 110 degrees or even much higher than that in degrees Celsius. And for the next 15 days at same location, there will not be any sunlight. So that's called the lunar night. And since you don't experience or don't receive the sunlight for next 15 days at that portion, the temperatures can plummet down to minus 180 degrees Celsius. So there are extreme temperature variability on the surface of Moon. We have this beautiful, thick, multi-layered atmospheric system which protects us from various harmful radiations and gases like, ultraviolet radiation, which is protected by ozone layer. Then there are other, like ionosphere, which protects us from the solar wind and solar plasma, and also provides mild greenhouse effect so that our temperature remains warm enough and we get comfortable surface temperatures on the surface of Earth. But on the Moon, its gravity is almost, very less, or 1/6 of the gravity of the Earth, and with that gravitational attraction, Moon could not hold the atmosphere around it. And today we do not have any atmosphere. There are no gaseous molecules which are present on the surface of Moon. So basically, it's a body where the sunlight directly comes without any interference. There are no clouds, nothing, no winds, and that has its own hazard. That large amount of meteorites, which are basically there in our solar system, they keep on crashing onto the Moon's surface. One of the most important things for survival on Earth is water. And in fact, they say that the life follows the water. Wherever there are big river systems, or on Earth, wherever there is the availability of water, you will see there is abundant life, both the human life as well as the animals and even the biota, the plants. Like around the river basins, Amazon basin, around Ganga, most of the civilizations have thrived around river banks. But if you see, even on Earth, areas like Sahara or any other desert, there is a limitation of getting rainfall or less amount of water. You will see that life is not there. So the water is the most important component for survival of life, and Earth has plenty of water. In fact, we have more than 75% of our surface covered by oceans, which are full of water, and there is a good amount of freshwater resources, even in terms of water in rivers, in reservoirs, in North Pole, South Pole, in solid ice form, as well as on Himalayan and other mountain range in the form of snow and glaciers. However, on Moon, yesterday the speaker told you that we found water on Moon, but that water is not sufficient enough for any kind of life support, and that water is there only in the molecular form, not even in the flowing or liquid or vapor or in solid form as we speak. Of course, there are publications now which tells us that probably there could be water ice on the polar regions of the Moon, and I will tell you certain examples of that also. But in general, the Moon surface is very dry, and whatever thin amount of or less amount of water is there present or has been detected by the newer experiments, it is also in the molecular form, and in terms of concentration, it is only in parts per million, not abundant water form. So these are the two typical characteristics of these two systems, which are very different. Even though they are very close to each other, the distance of Earth to moon is only around 1,85,000 kilometers. With a good solid rocket, with a powerful rocket, one can reach only in 2.5 days to moon surface from Earth. And in fact, all of you may recall that during 1970 Cold War between USSR and Americas, they have landed, the astronauts on the moon surface. And we had this Apollo mission, and you all may recall the Neil Armstrong, who became the first astronaut to land onto the surface of moon. But apart from these three, those who were there in this Apollo mission, in total, I can tell you that 20 astronauts have visited the moon surface, and large amount of moon rock has been brought back to Earth for doing chemical composition analysis and to know the characteristics, composition of lunar rocks, and to understand more about the lunar geology. Now, if you see this picture, two pictures or two images, there are one on the left side and on the right side. These are the two hemispheres of moon. This side, which is visible from the Earth, the other side or the back side of the moon is never visible from the Earth. The simple reason is that moon and Earth is tidally locked. The moon takes same time to go around Earth and to rotate on its own axis. So that's why we are not able to see the far side or the back side of the moon from the Earth. So to get an idea about the far side of the moon, the only way is to go out of Earth or to send a satellite which can go around and which has some imaging cameras which can take pictures of the far side of the moon. So these images has been compiled by millions of such images which has been collected by satellites, and a mosaic of these images has produced the true global map of the surface of moon. Both this side we call as the near side, which we see from the Earth, and the other side which is called as the far side of the moon. Now, two characteristics differences you will see in these two sides of the moon. One noticeable thing is that you see two different kind of hues on this surface. One is the area which is very bright. Even if you see the moon by your naked eye, you will see brighter areas, and then of course there are very dark areas which are relatively very smooth also. They are not having topographical variations, as you have very high topographic variations on these brighter areas. Similarly, on the back side also you see large amount of brighter surfaces and very less amount of these dark surfaces. So these two surfaces has been given names by the geoscientists or geologists or lunar scientists. So the brighter surfaces are known as the highland regions. They are very high, topographically varying, very rugged, and they appear much brighter. The rocks are basically reflecting large amount of sunlight, and these dark areas are called the Lunar Malaise. Okay, and they are very dark. They absorb the sunlight, and the very less light is reflected from this malaise. In fact, on the near side, you have large number of mares exposed, but on the far side, such dark surfaces are very less. This is also a question that why you have more mare systems on the near side and why less on the far side of the moon. Now, what is this mare means? Mare is a Latin word. Basically, this name was given by the earlier astronomers who were trying to look at moon with the primitive telescopes, and they found that these surfaces were very smooth, and they were basically were looking like basins, which from those telescopes they thought that has some water because they were very smooth. And in Latin, mare is known as oceans. So they have given this name. The Latin astronomers of those times, they call these surfaces as oceans. But later on we found that there is no water, they are all rock forms only, and mostly they are basically the rocks which are commonly known as the volcanic rocks or basaltic rocks, which is made of the magma, which when it comes out due to the volcanic processes and cool down, it forms a rock called basalt. And these brighter areas are basically the rocks which are basically composed of lighter elements like calcium, aluminum, and silicate. Like the crust of the earth is also made of those elements, and they brightly reflect the solar light, and they are typically called the lunar highlands, or in geological parlance, I will not give you very difficult complex names. Geologists call them anorthosites. Okay, so the basic question, and one more thing which you will see, that the moon surface is having a large amount of these, craters. craters of varying size, It is simply because large amount of meteoritic showers. Since the formation of the solar system, large amount of activity in terms of, meteorites, asteroids, collision has led to huge amount of meteoritic shower. And since the moon does not have atmosphere like Earth, many of these meteors, they burn out because of friction in the atmosphere. They simply come and collide and forms this type of impact craters. In fact, on Earth also you find impact craters. In India, we have impact craters at Ramgarh in Rajasthan. There is a famous Lunar crater lake in Maharashtra, and there are other famous craters in Siberia, in Africa, as well as in America. But on Moon, both sides, you will find a large amount of craters of various magnitude and dimensions. So poetically, people say that they compare beautiful people, especially the ladies, with moon and call them Chandramukhi. But if you see the moon from very close, quarters, you will find so much of, undulations and these pits or craters that nobody would like to compare themselves with moon anymore. So this is the magic of space technology, that poets have to change their poetry. The science question is that how this moon has formed and what has been happening since the formation of moon. And today, as we live on the earth, our population is ever growing, our demand for mineral resources is also growing, and the way population is growing, the projection is that maybe by the end of this century, we may need 1.5 Earth, not one Earth may not be sufficient for our needs. So from where this half Earth will come? So now the scientists, technologists, and various countries are thinking that if they can send probes to moon and bring some lunar rocks back, then they can exploit these minerals which are present on the lunar surface, especially many of these rocks which are basaltic rocks. They are rich in iron, nickel, cobalt, even titanium and other minerals. And then probably now humans and big countries are thinking of exploiting lunar resources. So we have to also map that where are the different type of resources on moon, what kind of resources do exist. So all these scientific questions are deriving, today very ambitious programs by different countries for understanding various aspects of moon. In fact, China has a very extensive lunar program. Recently, they have sent a probe called Chang'e 5, which basically landed onto the moon surface and it collected lunar rocks and it flew back and brought a large amount of lunar rocks to the Earth. They have already demonstrated, of course, Americans have demonstrated these capabilities way back in 1970 itself. Russia had a very, very ambitious program to study moon, and Americans are thinking to go back to moon and put, human presence by Alchemist program, NASA Alchemist program, as early as by 2030 or so. India also has, Chandrayaan-2, Chandrayaan-3, and then we are also collaborating, as has been told to you, with Japanese to put a lander and rover in the form of next Chandrayaan mission, which will be a joint mission with Japan. So these were some of the drivers for the lunar programs. And yesterday, my colleague Dr. Anil Bharadwaj, he told you about the Chandrayaan-1 mission. I will not repeat this, but I will tell you that it was an international mission, and it had almost 11, instruments covering different part of electromagnetic spectrum. Now, all of you are aware, most of you are all science teachers, you are aware that the solar radiation, the sun which emits the radiation, it's not only the visible radiation which we see. The human eye is only susceptible or sensitive to the visible radiation, which is basically in terms of wavelength, we can say from 0.4 micron to 0.7 micron. But there is a large spectrum of energy which is emanated from the sun in the gamma ray, in X-ray, in ultraviolet, in infrared, far infrared, in microwave, and in terms of radio waves. So if we exploit all these wavelengths through the help of some sensors, specially designed sensors, we can get different facets and different type of information about the moon surface. So there was a high resolution camera to see the moon surface at 5 meters spatial resolution called terrain mapping camera. There were instruments which scientists call hyperspectral instrument, which captures reflected sunlight in different parts of electromagnetic spectrum, starting from visible to infrared. So using or analyzing this reflective pattern in different wavelengths, one can basically find out the composition or the rock types or mineral composition onto the moon surface. One can also find out the elemental abundance by the use of X-rays. Normally, the X-rays, which are brought by the sun's energy, they do get fluorescence. There is a fluorescence process happens, and this fluorescence, signal, when it gets reflected and recorded by a sensor, also provides you information about the elements which are present onto the moon surface. So one can do the elemental analysis and find out what kind of basic elements which you teach to students in your periodic table. Many of the elements which are found on Earth are also found on Moon, and people have made maps of these elements. So from these elements, the other compounds which we call minerals, they are formed, and from these compounds, the rocks are formed. So these are using different kind of instruments. One can reconstruct from the elemental abundance the rock composition of such planetary bodies. So three major scientific achievements of this mission, which lasted almost, for almost for 1.5 years or so, and collected large amount of data about the moon in, as I told you, different part of electromagnetic spectrum, and more than hundreds of papers, scientific papers, were published by Indian scientists as well as American, European, Japanese, Chinese. So many people have worked on this data because this data was provided and made public to various set of lunar scientists. They analyzed, and then if I have to provide you a summary of all those observations, three characteristics, scientific findings were brought out from this analysis, which were previously not known about the moon. One is that that moon has a tenus. Tenus means weak, but active hydrosphere. All of you must be teaching about the hydrological cycle of Earth. When the water gets evaporated, it gets lifted into the atmosphere, it cools down, it condenses, and then cloud formation takes place. And when the saturation happens in the cloud because of the gravitational attraction, the large droplets are formed and rain happens. And with rain, this water comes back to the Earth's surface. Some goes down into the Earth crust in the form of groundwater. And then again, this cycle continues, which is known as the hydrological cycle on Earth. Similarly, there is an hydrosphere or a hydrological cycle, which is not as active what we see on Earth, but it is there. So people have made maps of the lunar water. Here in this image, you see this blue areas. They were mapped to have, the water in the concentration range of around, tens of ppm to thousands of ppm, not more than that, parts per million. So there is a weak, molecular water which was found with the help of Chandrayaan-1 data analysis, and we are extending this experiment on our Chandrayaan-2. I will show you some results of that as well. The question was asked that how does this molecular water get produced on the sun surface, and there are certain scientific hypotheses to explain, especially with respect to the solar wind, which yesterday Dr. Hydrological talked about, that when this solar wind, which is energetic particles, when they collide with the moon surface, then they are basically liberating the hydrogen and oxygen, and which is present in the minerals itself. And then by formation of these two molecules or two atoms, the hydroxyl OH and H2O do get formed, and it gets transported from hotter regions to the colder region of moon. So this basically forms what we call as the hydrosphere on the moon. So this was a major finding of Chandrayaan-1 mission, and many of you must have heard in newspapers and other journal magazines that India, along with American scientists, found water on the Earth for the first time. So this is what is the story of that finding. Another major important finding was that initially, the thought process about moon was that there is not much of activity in terms of geological movement onto the moon surface as we have in the case of Earth. You have landslides, you have volcanoes, you have earthquake taking place, and we have active plate tectonics, which basically causes these geological movements on the surface. So previously it was thought that it's not there on moon. Moon's internal heat has subsided very fast, and that's why we do not have much of volcanic or geological activity. But the high resolution data. I can show you this picture. You may be seeing there is a fault over here, and this fault was imaged with high resolution data sets. And such type of faults, if are present on any planetary surface, they are indication of subsurface geological activity. In fact, with the Apollo missions, the astronauts have left certain seismometers on the surface of Moon, and they recorded what we have earthquakes. Similarly, they recorded extensive moonquakes, which basically gave an idea that internal dynamics is there on Moon, which is basically causing Moon surface to subside and earthquake activity to also occur onto the Moon surface. Then the third and most important aspect in terms of how the Moon was formed. So there is a hypothesis. Don't worry much about these technical words, ocean magma hypothesis or something. Basically, what it tells that if a body, planetary body, when it forms with a collision, it will be very warm. It will be molten or semi-molten. And with time, this heat will start cooling. And as it cools, with respect to the typical gravitational law, the elements which are heavier in atomic mass, they will sink. So heavier atoms like iron, nickel, cobalt, magnesium, they will go down in this melt. And the lighter elements like silica, calcium, and other lighter elements, they will float. So when they will come to the top of this, solution as it solidifies. So basically, the upper part of the crust of any planetary body should be made of the lighter elements, and the interior should be made of heavier elements. And that process or that hypothesis was called lunar ocean magma hypothesis. And we found with the help of these spectrometers that indeed the lunar surface is made of these rocks, which are basically composed of lighter elements. And of course, at places where you have the heavier elements, they have come up due to the volcanic activity. So these three major findings were the crux of the Chandrayaan-1 mission and became a very famous mission which changed our humans' understanding about the evolution, about the composition, as well as about availability of water onto the Moon surface. So in nutshell, this is what the findings were. I will take you through some of these images which were basically analyzed to derive this understanding. But first and foremost, I will tell you about a very important process, which is called impact cratering process, and why so many impact craters are there Moon, and how these impact craters become very important scientific sites for studying the composition, especially the interior composition of the Moon. So this is a meteorite. Let's say if a cartoon, a meteorite is basically approaching the lunar surface, it will have first contact with the surface. As it collides, it will splash large amount of material. Then a transient cavity will be formed, and the material will be thrown out. You can do these experiments in your lab and so, or some of you, if you have thrown a stone in pond, you will see that splashes. So similar type of splash of rocks will happen, and this is called ejecta. And within no minute, within few minutes or seconds, this type of deep impact craters will be formed if the impactor size is much larger. And if the impactor is much large, then you get this type of complex craters, which also will have a rebound from the surface and will have what we call as a predominant central peak. Basically, it happens because of Newton's law of action versus reaction. So in all craters, you will not find the craters which are smaller than 35 kilometers. Central peaks are not well developed, but in large craters on Moon or on Mars, you will find, or any other planetary body which is atmosphere or airless, you will find this type of central peaks. So this type of craters, they do get formed within no seconds because such type of meteoritic impacts happens. And of course, on Earth itself, large amount of meteoritic activity has happened. And today it has been proven conclusively that the dinosaurs, which were basically in the Jurassic era, they were dominating the Earth's surface in terms of organisms which were dominating the Earth, like the humans are dominating today. They vanished simply because of a meteoritic impact somewhere today where we have this Gulf of Mexico. And that impact was so huge that it changed the atmospheric composition and temperature regime of the Earth, and many of these creatures at that time could not survive. And so that's why the impact cratering and the impact cratering process in our neighborhood is a very, very important phenomena to learn that what these impacts can do to the surface and what will be their consequences. Now I show you a beautiful image which has been captured by our own Chandrayaan data sets or Chandrayaan imagers. And this image is basically of a crater which has been named on a name of a famous astronomer called Tycho, Brahmi Tycho, which is a French astronomer. And if you see moon, on a full moon day or full moon situation, this crater you can see from your naked eye, or maybe if you take a good camera, maybe a zoom camera, 30x or 40x zoom digital camera, you can capture. So here in the southern portion, you will find this bright, crater over here, and with a beautifully developed ray system. So this crater, if we image from 50 kilometer, 100 kilometer distance from moon, this is how it looks like. Such a beautiful crater, and this has a dimension of 85 kilometers. So from one flank to another flank, you have to travel 85 kilometers. It's a huge crater. And there is a beautiful, central peak of this impact crater over here called Tycho's central peak. And this central peak has a height of around 2 kilometers or so. And these are the crater rims. So if you fall from here to this bottom, you will be falling roughly around 4 kilometers or so. And these are, so-called terrace systems. These are typical staircases or steps. You can basically walk into the floor of this crater, Tycho crater, and this is basically the floor of the crater. So this type of craters you find on Earth also. As I told you, the famous crater in Maharashtra, in Buldana district, is typically of that. And on Earth, the difference is many of these craters, because we have rain and other things, they are now, most of them are filled by rainwater. But of course, on Moon, you don't have such luxury. So they are all dry and only are made of pulverized rocks, or rocks which basically got damaged because of such a large, massive hit. Now, this is another close, photograph which was collected by our terrain mapping camera, which also incidentally has a capability to have three-dimensional imaging through photogrammetric, techniques. So don't worry about these words. It is as simple as understanding, like we have all creatures have two eyes. Why the God has given us two eyes? We could have managed with one eye also. But to have the perception of depth, it is important to have two sensors separated by a distance, so that one can have a depth perception. So similarly, if you put two sensors on a satellite separated by a distance, you can view the same area in different angles, and using some set of equations of mathematics, which is defined by a science called photogrammetry, you can reconstruct the height or the depth of that area. So using this type of techniques, we have also derived what we call the elevation or digital elevation of Moon. And today we know that at what height, at what location, what is the height of the surface at Moon. So this is particular, the central peak. Here the height is around 2 kilometers. This is the bottom. And then there are depressions. You can see the landslide or sliding, rock flows. And then, of course, there are fractures on the surface of the Moon also. So such kind of detailed maps are available today of the Moon surface, which tells you that many of these landforms which you see, suppose if you visit, let's say Dehradun, you can also find such type of hills. Only difference will be these hills will have, the vegetation present on them. But since on Moon there is no air, no water, no photosynthesis can happen, so they are all bare rock forms which are exposed to the solar wind or to the sunlight. This is another interesting kind of landforms you will find on Moon. They are called impact melt. So what happens when these meteorites, they hit the rocks basically, they produce so much of, from this potential energy, so much of kinetic energy is produced that at the location of impact, these rocks will start melting because of the friction and the energy which is brought by these meteorites. And when they start melting, they start flowing. So this is a kind of a rock flow which is basically now preserved. Of course, the Moon has cooled down since the formation of these craters, but you can still see the wave or the wave pattern in this fluid material, which must be fluid at one time. But later on, with the reduction of temperature and cooling process, I told you the night temperature